Hello everybody and welcome. In today's video we're going to be going over applications of systems of equations, or pretty much the word problems that we all love so much, and we're going to be going over 5 examples of those. So without further ado, let's get it. Example number 1. So we have Ross and Carolyn combined their DVD collection when they got married. Ross had 42 more DVDs than Carolyn had. Together, they have 148 DVDs. How many DVDs did each person have? I don't know who uses DVDs anymore, but that's besides the point. So what we want to do is first, I want to kind of set my variables. I'm going to have my variable R equal to Ross's number of DVDs. So I'm just going to put Ross DVD number. And then C is going to be equal to Carolyn DVD number. All right, so with word problems, what we're basically trying to do is write two equations that represent the problem and solve them. So I like to pretty much get my variables here, R and C, off the jump. So that way when I write my equations, I already kind of know what I'm solving for. And what you want to do whenever you do have word problems is they give you a couple of key points here to note. So the first one is this one. Ross had 42 more DVDs than Carolyn. So what that means is that if you're to take Carolyn's number of DVDs, which is C, and add 42 to that number, you get the number of DVDs that Ross had. Okay, so that's going to be our first equation. Now, the second key piece of information they tell us is that together they have 148 DVDs. And what that means is that if you were to add Carolyn's plus Ross's DVDs together, it's going to equal 148. And that is going to be our second equation. Okay, so what we want to do is get from here, all we got to do is really just solve the system. And what we want to do is you can use either substitution method or the addition method. I like using the addition method more. So the way we do that is we want all of our variables in both equations to be on the left-hand side and then the numbers to be on the right-hand side. So I'm actually going to go ahead and do that. So equation number 1 here, let's change this up. So we have C plus 42 is equal to R. And I want to get this R over to the left-hand side and this 42 over to the right-hand side. So what that means is that I have to subtract R from both sides. And I also have to subtract 42 from both sides. So subtract 42 and subtract 42. All right, so when we do the math here, these two 42s cancel. You'll get C minus R is equal to, and on the right-hand side, the R's cancel out, and you just have negative 42. So this is going to be our new equation number 1 here, where the variables are on the left-hand side. All right, so now let's continue. I'm going to start writing on the right-hand side of the screen. So equation number 1 is now C minus R is equal to negative 42. And our equation 2, everything looks good there. So I'm just going to go ahead and write C plus R is equal to 148, like that. All right, and now I'm going to add these two together because I know that these R's here will cancel out. So when we add these two equations together, you'll get 2C is equal to 148 minus 42 is going to be 106. And now all we have to do here is divide by 2. Divide by 2. These 2's cancel. And we're going to get C is equal to 53. Okay, so that is one of our answers. And now to find out how many DVDs Ross had, we can plug this C equals to 53 into either equation 1 or 2. And I'm going to go ahead and plug it into equation number 1 here. So we have C, which is 53, plus 42 is equal to R, which is Ross's numbers of DVDs. And then when we do the math here, we get Ross has 95 DVDs. So Carolyn with 53 and Ross with 95. We found out how many DVDs they each had. Therefore, this example is complete. Example number 2. The length of a rectangle is 5 feet more than twice its width. If the perimeter of the rectangle is 124 feet, find the length and width of the rectangle. Okay, so in this case, our variables L is going to equal length, W is going to equal width. And what I'm just going to do here is draw a simple rectangle here just to kind of visualize what we got going on. So the length, I'll say, is this. The width is this here. And that just kind of helps visualize what's going on. So what we want to do is write two equations, and we're given some key pieces of information here. So the length of a rectangle is 5 feet more than twice its width. So sometimes you kind of just like have to just sit there and kind of think about what it's saying. So I'm just going to put the length, and it says the length is, so that means I'm going to put an equal sign. So the length is 5 feet more, so 5 feet more than twice its width. So 5 plus 2w. 5 feet more than twice its width. Okay, so that right there is our equation number 1. And equation number 2, let's look at the problem again. It says if the perimeter of the rectangle is 124 feet. So the perimeter of a rectangle is equal to 2w plus 2l. Perimeter is just adding all of the widths and lengths together. So if you look at this rectangle that we drew, there's two lengths and two widths. So if you were to add those all together, this formula here for perimeter is like the simplified version of that instead of putting L plus W plus W. So we know that 2W plus 2L is equal to, the perimeter is 124 feet, and that 124 was given. All right, so now we have our two equations here. And like I said, I like using the addition method. So what I'm going to do is rewrite equation number 1 so I can get all of the variables on one side. So I'm going to go ahead and put 1 and a star here. And we got L is equal to 5 plus 2W. And I want to move that 2W over. So I'm going to subtract by 2W. And when we do that, our new equation 1 becomes L minus 2W is equal to 5. All right, so now let's go ahead and rewrite our equations again. So equation number 1 is L minus 2W equals 5. And equation number 2 is 2L plus 2W is equal to 124. And as you can see, I just moved around the L and the W here just so I can get those, above one another. All right, so what we see here is that when we add these two equations together, these W's will cancel. So let's go ahead and do that. So L plus 2L is equal to 3L. 3L is equal to 5 plus 124, which is 129. Now to solve for L, we divide by 3. And then what we get is L is equal to, let's type this in the calculator real quick. Maybe I should have done it beforehand, but we can do it together. So L is equal to 43. All right, so we found out one of our answers here. Now what we need to do is find the width. So I'm going to go ahead and plug that into any one of these equations. So I'm going to go ahead and plug this into equation number 1 here. And when we do that, we get L, which is 43, is equal to 5 plus 2w. And now we subtract 5 from both sides. And what we get here is 38. I'm going to write it over here. So 38 is equal to 2w. And now to get w by itself, we divide by 2. These two cancel. Therefore, we get w is equal to 19. All right, so we found our length, we found our width. Therefore, this example is complete. Example number 3. We have Serena invested $8,000 in 2 CDs. Some of the money was deposited in a CD that paid 7% interest, and the rest was deposited in a CD that paid 6% annual interest. If Serena earned $530 in interest in the first year, how much did she invest in each CD? So initially, when I'm looking at this problem, I think Serena's financial advisor should be fired because you should have put all your money in the 7% CD because you get paid more, but that's besides the point. So what we want to do when we always want to start off is define our variables. So in this case, I'm going to let X represent the amount of money for the 7% interest CD. And I'm going to let Y equal the amount of money for the 6% interest CD. All right, so we have our variables listed out here. And now what we want to do is write the equation. So we want to look at the problem here and get some information. So the first sentence, it says that Serena invested $8,000 in the 2 CDs. So that means that the amount of money in the first CD plus the amount of money in the second CD has to equal 8,000, which is her initial deposits. Okay. And now for the second piece of information for our second equation, we know that Serena earned $530 in interest. All right. So for equation number 2, we know that 7% 0.07 of the initial deposit in that account, which is X, plus 6% 0.06 of the initial deposit in that account, which is Y, is going to give us $530. Let me erase that here. So $530. So 530. Okay, and let me just explain equation number 2 just a little bit. So whenever you're dealing with percents, you want to change that into a decimal, and the way you do that is by moving the decimal 2 spots to the left. So that's why I have 0.07 here, and that is 7% of our initial deposit, which is X here. So these right here are initial deposits. All right. So let's go ahead and I'm just going to rewrite these real quick. So we got X plus Y is equal to 8,000. And 2 is 0.07x plus 0.06y is equal to 530. And I'm not too big of a fan of decimals, so what I want to do is multiply equation number 2 by 100. So I want to multiply by 100 to equation number 2. All right, and that way we can get rid of the decimals. So I'm going to rewrite equation number 1, which is x plus y is equal to 8,000. And our equation number 2 then becomes 7x plus 6y is equal to 530 times what times 100 is 53,000, like that. All right, so now we got our 2 equations. We have all the variables on one side, all the numbers on the other side, and what we want to do is try to cancel out one of the variables. So when I'm looking at this here, I want to go ahead and cancel the y's. So what I'm going to do is multiply equation 1 times -6. All right, so that means I'll get a -6y and we can cancel. So we multiply the top one by -6, and then we add the equations together. And what we get is -6x minus 6y is equal to -6 times 8,000 is -48,000. So that's equation number 1. Equation number 2 is 7x plus 6y is equal to 53,000. All right, and now we can add these together. So we will get x is equal to 5,000. All right, so that is our first answer here. Now what we want to do is find y, and the way we do that is we're going to go ahead and plug this into equation number 1. So x is 5,000 plus y is equal to 8,000. And we are going to go ahead and get y by itself, so subtract 5,000 from both sides. And then what we get when we do that is that y is equal to 3,000. All right, so x is equal to 5,000, y is equal to 3,000. Therefore, this example is complete. Example number 4. We have Bob works at a coffee shop that sells Kona coffee beans for $40 per pound and Colombian coffee beans for $15 per pound. The coffee shop also sells a blend of the two beans for $20 per pound. If Bob's boss tells him to make 30 pounds of this blend, how much Kona coffee and Colombian coffee must be mixed together? All right, so the first thing I want to do is set my variables. So I'm going to let K here equal to the pounds of Kona coffee. So pounds of Kona. And then C is equal to pounds of Colombian. All right. And now what we want to do is try to figure out two equations so we can have a system and solve. So looking at the problem here, one piece of information is that Bob's boss tells him to make 30 pounds of this blend. All right. So what that means is the blend is a mixture of the Kona and the Colombian. So our Kona pounds plus our Colombian pounds has to equal 30 pounds of that to make that blend, right? And the other piece of information is a little bit harder to get. So we want to make 30 pounds of this blend. Let's find out what's the price of making this blend. So if they are selling this blend for $20 per pound, that means that the cost for the blend to make 30 pounds is 30 times $20. So that's the total cost to make this blend. So now let's figure out what the cost is of the other ones per pound to make up that $600. So the way we do that is the Kona coffee, it sells for $40 a pound up there, that's given. So $40 per pound of the Kona coffee plus $15 per pound of the Colombian coffee has to equal $600 because that's how much 30 pounds of the blend cost. Okay, so I'm going to just erase the dollar sign there. So those are our two equations. All right, so now what we want to do is solve this here, and I'm going to use the addition method again. So I'm going to multiply equation 1 by -15 so we can cancel out the c's. So equation number 1 becomes -15k minus 15c is equal to 400 negative 450. And equation number 2 remains the same at 40k plus 15c is equal to 600. All right, so from here, what we're going to do is add these equations together. And I'm going to write that on the right-hand side. So negative 15k plus 40k is equal to 25k. The c's are going to cancel out. And then we got negative 450 plus 600 is equal to 150. And to get k by itself, we divide by 25. Divide by 25. So those 25s cancel. And we get that k is equal to 6. Okay? And now we have our k. What we're going to do is plug that k into equation number 1 here to find our c value. So k is 6 plus c is equal to 30. Subtract 6 from both sides. And when you do that, you'll get c is equal to 24. And you have your k and your c values. Therefore, this example is complete. Example number 5. We have Efrain is finishing his training for the Shaver Lake Triathlon. Yesterday, he focused on running and biking, spending a total of 5 hours. Efrain runs at a speed of 10 miles per hour and rides his bike at a speed of 30 miles per hour. If Efrain covered a total of 120 miles yesterday, how much time did he spend running and how much time did he spend biking? Okay, so what we want to do first is define our variables. So I'm going to have x equals to how much time did he spend running. So x is going to be equal to time running. And then y is going to be equal to time biking. All right. So now what we do, we have our variables defined, is we want to write down our two equations. So let's start off with our first one. And when we're reading this, it says that he spent a total of 5 hours running and biking yesterday. And then we set our variables to be time running and time biking. So we know that x plus y is going to equal to 5. The time he spent running, the time he spent biking is going to be 5 hours, which it states in the problem. All right. So now to find our second equation, let's see what else they give us. So 10 miles per hour, and we have 30 miles per hour, and we have 120 miles. Okay, so whenever we're given distances and rates and times, there is a formula that is distance is equal to rate times time. So distance in this case is our 120 miles, so the length pretty much. The rate is the miles per hour, and the t is the time that it takes, which is the variables that we have. So what we know is that the rate of uh, the rate of running is 10 miles per hour, and then the time is x, which is what our variable is, time running, plus the rate of biking, which is 30, times the time biking is y, is going to be equal to 120. All right, so that's our distance is equal to rate times time formula there. All right, so what we do now is solve the system here. So I want to eliminate x. So what I want to do is multiply equation number 1 by negative 10. And when we do that, we will get negative 10x minus 10y is equal to negative 50. And that's our equation number 1. And equation number 2 stays the same. I'm just going to write that down right under it. 10x plus 30y is equal to 120. And now I want to add equation 1 and equation 2 together. When we do that, the x's cancel, which is what we wanted to do. Negative 10y plus 30y is equal to 20y, and that is equal to negative 50 plus 120 is 70. All right, so now what we want to do is isolate y by dividing by 20. And then I'm going to go ahead and continue this up here. So we get y is equal to 70 over 20. And we can simplify this. You pretty much cancel the zeros. So what we get is y is equal to 7 over 2. All right, and that is our y value. Now what we want to do is find our x value, and we take this y that we found and we plug it in to equation number 1 here. So we have x plus 7 over 2, which is our y, is equal to 5. And then we subtract 7 over 2 to both sides, over 2. And what we get here is x is equal to, so 5 would be 10 over 2 minus 7 over 2 is 3 over 2. All right. And the last thing that we should note is we want to make sure that we write the proper units. So these times are actually in hours, since that's how we've been measuring this whole time. So we know that he spent 3/2 hours or 1.5 hours running and 3.5 hours biking. So therefore, we found our x and our y, and this example is now complete.